Okay, today we'll start with the first program, which is finance algorithm. So first question is we have to implement and demonstrate the finance algorithm for finding the most specific hypothesis based on given set of training data samples, and I need to read the training data from a CSV file. So what it shows means we need to uh, implement the and demonstrate the finance algorithm for the what we are getting the training, what we are inputting the data input data as uh, enjoy sport data here in the in .csv file. We are we are implementing the input data into the program, that is enjoy sport data we are implementing into the system or into the program. So through the implementation, so we have to check which is the maximally specific hypothesis to which is to enjoy the sport. Maximally specific hypothesis means here we are giving the input data as enjoy sport, that is we are checking the which is the most preferable temperature or most preferable day to play a sport. So for that we are checking. So we are giving the input data in CSV file, and we are demonstrating using finance algorithm. So we'll start with what is finance algorithm. So it is a finance algorithm is an it will comes in the classification of machine learning. So then finance algorithm shows there are some steps are there in finance algorithm. The first step has to initialize the h need to initialize h to the most specific hypothesis in h. Small h is the hypothesis number of hypotheses, and then capital H is total hypothesis space. Capital H specifies the hypothesis space. Hypothesis space means group of hypotheses. So small h represents the hypothesis, single hypothesis, but capital H represents the group of hypotheses. And then the second step is for each positive training instance X. For each positive training instance X, we need to check for each attribute constraint A in H. So need to check each attributes in the in constraint. Each attribute constraint A means attribute one single attribute constraint is equated to A, and then those attribute constraints are present in one single hypothesis, which is represented by H. And then we need to check the condition if the constraint A is satisfied by X. If the constraint is satisfied by X means we have to check what is there in X means X contains the positive training instance, which will check only the positive training instances. So for that purpose, we have to check whether the hypothesis or the constraint which is taken is positive training data or negative training data. So if the constraint is positive, then only it will agree. So if the constraint is not positive, then it will leave that. Okay, then if the constraint is positive, if the condition true, then do nothing else. Replace by A. So A replace A in H by the next more general constraint that is satisfied by X. So if the constraint is not satisfied, then that constraint has to be replaced with next more general constraint that is satisfied by X. So if the constraint is satisfied by X, then we should not do anything. So if the constraint is not satisfied means, so we need to replace that constraint with the next more general constraint that is satisfied by X. So this is the second step. And then the third step is need to output the hypothesis H. Hypothesis H represents the more generic constraint, so that have to more hypothesis H represents the more generic constraints, so that we have to output. So this is the finance algorithm. These are the steps of the finance algorithm. Well, and then this is the training data what we have taken in this program. So this training data contains the enjoy sport data, and that will tells the temperature, humidity, wind, water, and forecast of a particular day, that the day has to be chosen to play some games. Then the first column, first row specifies the attributes or the constraints in the hypothesis. So here we are taken four hypotheses. Each row represents the single hypothesis. So in the first row, the hypo constraints attributes in the first row represents the attributes, and the next rows are values for those attributes. So sky, temperature, humidity, wind, water, forecast, target value, these are all the attributes. And for attribute sky, so to the total there are two attribute values, sunny and rainy. And for temperature, total there are two attribute values, warm and cold. And for humidity, total there are two values, normal and high. For wind, that is only single attribute value, that is strong. And for water, total there are two attribute values, that is warm and cool. For forecast, total there are two attribute values, which is same and change. For the target value represents the target hypothesis or target attribute values. These target value represents the positive and the negative constraints which are positive or negative. Yes represents the positive constraint and the no represents the negative constraint. So capital H represents the hypothesis space. Hypothesis space means group of hypotheses. Then small h represents the single hypothesis, and question mark represents the more general hypothesis. We will start with the step 1. In step 1, we have to consider the first hypothesis. So first hypothesis will take as it is as for the more general hypothesis. So we'll start with the next. We have to compare the more generic hypothesis with the first one. First hypothesis values. So hypothesis values are sunny, warm, normal. So this first hypothesis is a positive hypothesis, so that we have to take this constraint. The first constraint is the constraint values of the first constraint is positive. So then we are taking that value, we are considering that hypothesis. And in first step, the output of the constraints is same, which should not be changed. Why? Because all the hypotheses are the same, that is first hypothesis, so that we should not compare with anything. So we'll copy the same constant values. So then we'll move to second step. Second hypothesis is also the positive hypothesis. So then we have to consider that hypothesis, and then we have to compare the values with the second hypothesis with the previous more specific hypothesis, that what we have required with the step 1. So this is the value of the step 1, so that we output of step 1. So this we have to compare with these second hypothesis constraints. So this is also positive, we need to take this hypothesis, and then we have to compare this. So sunny and sunny, which is same, so it should not change anything. So we have to save that as same. And warm, that is also same, need to copy the same. So here humidity is high, but here normal, that is replaced with question mark. Why? Because we need to make more generic hypothesis, more generic, but that is maximally specific. More generic means maximally specific. We have to make the hypothesis as a maximally specific hypothesis. So for that purpose we are changing the value to question mark. Question mark means should be anything. Okay, then we'll move on to the next value, which is wind is having the strong, and here also strong, there is no change here. So we are copying the same. Here also warm, there is no change, so we are copying the same. And here also same and the same, the same thing we are copying. So this is the end of the second step, and we'll move on for the next one. Next step. So the third constraint is having the negative value. So here the third hypothesis having the negative target instance. So for at that time we should not consider this hypothesis. Okay, here in this step it will copy the previous hypothesis values here. So it will copy the previous hypothesis value and will move on for the next. We should not do anything here, and then we'll consider with the next hypothesis values. So we'll check with the target value which is positive value. We need to consider this hypothesis. Then we have to compare the previous step hypothesis, more generic hypothesis value with this hypothesis. So then here we'll compare with the first one, sunny and sunny. There is no change here, so we'll directly copy the same thing. So here warm and warm, there is no change. We'll directly copy the same thing here. I and question mark. So this will be replaced with a question mark, and then there is strong and same. Strong, there is no change. We'll copy the same, and here for water there is cool and warm. But here we need to change the value to question mark, that is warm and cool replaced with a question mark. Why? Because should be, this is the positive example, so it should be anything warm or cool, which it should be anything. Water will be anything, so that is replaced with a question mark. And then in forecast there is change here same, and that is also replaced with the question mark. Why? Because this is a positive instance. We need to consider this positive instance. So for that purpose we are changing the values. So this is the required maximally specific hypothesis, that is more generic hypothesis. Maximally specific is also called as more generic hypothesis. So that this is the required maximally specific hypothesis. For this required values, for this required constant, we can play the enjoy sport. We can play the sport, we can enjoy the sport. For this, the sky should be sunny and temperature should warm and humidity should be anything, and wind should be strong and water should be anything, forecast should be anything. At this particular condition we can able to play the game. This shows that. Okay, so we'll move on for the program. This is the output of finders algorithm. So like this algorithm will work. Then we'll move on for the program. See, this is the program, and the algorithm is used, finders algorithm is used to find a maximally specific hypothesis. We start off with a more specific hypothesis, and based on the training examples we end up with a maximally specific hypothesis for the target concept. And the description of the algorithm is shown below. So the description of the algorithm is, we need to initialize H to the most specific hypothesis in H for each positive training instance X for each attribute constraint A in H. The constraint is A is satisfied by X, that is whether the constraint is positive, then do nothing else, replace A in H by the next more general constraint that is satisfied by X output hypothesis H. We'll start with the first one. Need to import the pandas. Pandas is a library function. We need to import this pandas. Pandas must be installed with the .pandas used for reading the data from CSV file. So here pandas is used to reading, pandas library is used to reading the file from in the CSV format, and then read it, what the file has been read, and that is the file name is enjoysport.csv, and that is initialized to data. So here ensure this is what why we are using, means we are ensuring the CSV file exists in the same folder as a Python code. So Python code, here we are copying this the CSV file to the data, and then here the value, the number of columns we are using, we are obtaining the how many number of columns are there, and we are obtaining the total length of the data. So how many number of columns are present in the data, and then we are obtaining the number of rows, how many rows are there, how many columns are there, we are obtaining that, and we are printing the data. So what we have fetched in the CSV file, that those data will be printed here. So then we are initializing the most hypothesis for as a question marks, sorry, as a zeros. So most hypothesis values are initialized by the zeros, and most more maximally specific hypotheses are initialized with question marks. Okay, then this in hypothesis h of 0 comma 0 comma 0 comma 0 comma 0 represents the most specific hypothesis which are initialized to h. And then HP we are initializing to list of hypotheses for positive training examples. So HP means hypothesis positive, positive hypothesis. HN means hypothesis negative. How many negative hypotheses are there? For to represent the negative hypothesis, we are initializing here. Then we are using the for loop. This loop is used to build the hypothesis list for every row, and we are initializing the list training examples here. So list of training examples we are initializing here, and then this training example contains the first attribute values, that is sky, and the air temperature is the second attribute values, and the humidity is the third attribute, wind is the fourth attribute, and water is the fifth attribute, data forecast is the last attribute. If the enjoy sport, which is enjoy sport is having the total number of data, the if the training example is positive, then only it will get inside the loop. If the training example is negative, it will append, and then it will check with the negative examples. Then it will check with each and every values in the constraints or in the hypothesis. It will check with each and every values with the hypothesis, and then if the values are, if the hypothesis is positive, then it will replace the zero as the question marks. So then it will print the final hypothesis, or that it required final required hypothesis. It will print the final required hypothesis, and it will print both the positive hypothesis, negative hypothesis, and maximally specific hypothesis. It will print everything. Here, the input data has been printed. After printing the input data, it will print the positive hypothesis. How many positive hypotheses are there? Total here, total we have taken three hypothesis values. So three hypotheses, and then based on among three, total there are sorry, four hypotheses. What we have taken four hypotheses. Among four hypotheses, we have taken the three positive hypotheses and one negative hypothesis. So among four, we have taken three positive and one negative hypothesis. So these three hypotheses, positive hypothesis, are printing here, and the negative hypothesis which is printed here. So then at last the required maximally specific hypothesis has been printed like this. Hypothesis. This is the maximally specific hypothesis. If you have any doubts, you can ask.